Hello there, welcome to the A-Level Maths Pre Paper 2 of June 2023. Here we're looking at question 11. A tank in the shape of a cuboid is filled with water. The base of the tank measures 20 metres by 10 metres and the height of the tank is 5 metres as shown in figure 1. At time t metres after water started flowing into the tank, the height of the water was h metres and the volume of the water in the tank was v metres cubed. In a model of this situation, the sides of the tank have negligible thickness and the rate of change of v is inversely proportional to the square root of h. Show that dh by dt is equal to lambda over the square root of h, where lambda is a constant. Okay, so the first thing that stuck out to me is that this sentence here is going to give us a differential. The rate of change of v, so this expression itself, is going to tell me what dv by dt is equal to, because rate of change is always dt on the bottom, and if it's of v, then it's dv on the top, equals inversely proportional to the square root of h. So inverse means that it will be a fraction. Square root of h means that square root of h will need to be on the bottom, and it will need to have some scale of proportion, which is k on the top. So I've got dv by dt, now I need to work out dh by dt. So I need to get rid of a dv and put in a dh somewhere. So I think I'll need to work out what dv by dh is equal to. But first, the first thing I'll need to work out is an expression for volume in terms of height. And we can work this out from the shape that we've got here. If we look at the shape, it's 20 meters wide, 10 meters not deep, I don't want to say deep, but 10 meters in this direction and h meters deep. So the formula for the amount of water in this cuboid at any one time is 20 by 10 by h, which simplifies to 200h. So now that I've got a formula that says v equals 200h, I can find dv by dh. If you differentiate 200h, you get 200. Right, so now I need to connect these two rates of change. So this one here will need connecting to this one here. If I want to work out dh by dt, then out of one of these two formulas, I need a dh on the top. The first one that we worked out up here doesn't have a dh in it. The second one that we worked out does have a dh in it. So I'm going to flip over that derivative. In the next line, it's going to become 1 over 200. And then I'm going to multiply by dv by dt. And I definitely know this is the correct thing to do because I want to work out what dh by dt is. I've got dh on the top, dt on the bottom, and a dv on the top and bottom, which will cancel out if you think of these as multiplying fractions. So this is now going to be dv by dt, which is k over root h, which simplifies to k over 200 root h. So therefore, if we now just simplify our constant, lambda is k over 200, we get lambda over root h, where lambda is a constant. Don't know what the value of the constant is, but I know it's just a constant. So there we are, that's the answer to part A. Moving on to part B now. Given that initially the height of the water tank is 1.44 and exactly 8 minutes after the water started to flow into the tank, the height of the water was 3.24. Use the model to find an equation for h and t, giving your answer in the form h to the 3 over 2 equals at plus b, where a and b are constants to be found. So we know in our formula that dh by dt is lambda over the square root of h. This is a differential equation where we need to multiply the h onto the other side, and we'll leave the lambda where it is, so it's lambda dt. We're then going to integrate both sides of the equation. So we've now got an integral with respect to h and an integral with respect to t. So for the h equation, we increase the power by 1, divide by the new power. And on the right-hand side, we integrate with respect to t, so it's just a number we're integrating here, so it's lambda t plus c. Okay, the first thing we now need to do is use the first condition here, that initially the height of the water tank was 1.44 meters. So that's when t equals 0, h equals 1.44. So let's substitute this into the equation. 2/3 times 1.44 to the 3 over 2 equals 0 lambda plus c. So we're going to work out c from this expression here. So go to the calculator, and it's going to be fraction button 2/3 times 1.44 to the power of 1.5, and that gives me 144 over 125. Lovely. So now my formula is 2/3 h to the 3 over 2 equals lambda t plus c, plus 144 over 225. Okay, so let's now plug in exactly 8 minutes. Let's just go back and check the question is in minutes, because I don't want it to be actually be in seconds yet. T is definitely in minutes, so that's good. T 8 minutes, the water flowing into the tank of the water was 3.24. So we're now going to substitute in 3.24. So 2/3 times 3.24 to the 3 over 2 equals lambda times 8. Add 144 over 125. And when you solve this, I'm going to try and do a good amount of this work on the calculator now. So you get 3.24 to the power of 1.25 times 2 over 3. Take away the 144 over 125 on the other side. Then we're going to divide by 2 and times by 3. No. We're going to divide by 8 to get lambda. It's 171 over 500. So therefore the equation is now 2/3 h to the 3 over 2 equals 171 over 500 t, add 144 over 125. If we now rearrange this, h to the 3 over 2, so we times by 3 and divide by 2, we get 513 over 1000 t, add then the 144 over 125, times by 3, divide by 2, we get 216 over 125. And there we are, that's the answer to part B. Now A is 513 over 1000 and B is 216 over 125. Part C, find the time taken from when the water started to flow into the tank for the tank to be completely full. We need to go back to the first page to see that the height of the tank is 5 meters. So let's plug in 5 to the 3 over 2 equals 513 over 1000, add t, add 216 over 125. So let's do that on the calculator now. 5 to the power of 1.5, add 216 over 125, divide by 513, times by 1000, and we get an answer. And this gives an answer of t equals 18.42. And if we were to put this into minutes and seconds, that is 18 minutes, pressing the commas button, and 25 seconds. And there we are, that's the answer for question 11, worth a total of 10 marks. Let's now move on to question 12.